Hi Prof and Assistant Prof, we are Kawaii Sushi from G2T7. I'm Rohit and my fellow group mates include Richie, Jingting, Qinglei and Glenn. So this is our agenda for today. Firstly, we will walk you through the scenario overview and demonstration within each scenario. Secondly, the basic features within each scenario. Thirdly, the additional features we have incorporated for the project. And lastly, our technical overview diagram. So these are the three main scenarios that we will focus on. For the first scenario, it's a customer placing an order, where we have broken down into 4 steps. So the login to Facebook to get restaurant upcoming events, followed by entering order details, and entering the Telegram handle, and lastly, placing an order. So for the second scenario that we are looking into is the chef receiving an order request, and for the third scenario is customer checks the bill and make payment. So now I'll pass on my time to Richie, who will be going through the first scenario where the customer places an order.
So now we'll take a look at the first scenario, which is customer place an order. In this customer place an order, we have made use of the Facebook API and the Telegram API. And with that, we also make use of the microservice like sushi order and menu. So for the first part of this scenario, the customer will log into the website by using their Facebook account, which they will enter the Facebook account details like their email and password, and it will return and show the restaurant details, locations, and upcoming events detailed information. So with that, we have made use of the Facebook API in this segment. For the second part, we have the customer create an order. So the customer will need to enter the order details, for example, the table number, the order ID, the item price, the tally user, and the chat ID, which is generated by the microservice itself. And it will return an order created ID for the user on the ordering UI. So with that, we have made use of the Telegram API, which will send a confirmation message and return the confirmation message. Lastly, we will take a look at how the customer will browse the menu and place an order. So the customer will browse and select through the sushi app or website, and then they will get the price, which the system will return all this and display the sushi price and the quantity. And the second part, the customer will select the items, and then they will create a sushi order details, and these will return the sushi order details created, and these orders can be displayed. With that, we have made use of Docker for the menu segment of this particular microservice. And also, we have also created using HTTP post to create a sushi order details, which will return the sushi order details that is created. And in scenario 1, the basic requirements we have met is that we have microservices like the menu and the sushi order itself. And for the user interface, we have made use of the HTML, JavaScript, and JSON. And database will be menu and the sushi order.
So welcome to Kawaii Sushi. So now we'll move on to the demonstration where we will actually break down into 3 different parts of the scenario. So we have for this demonstration, we actually have 2 main leads, which is Glenn, who will be the sushi chef, and also Richie, who will be the liang POPO in this demonstration. So now for this demonstration, we'll move into the first user scenario where a customer places an order. So which is liang POPO enters an atas restaurant, sushi restaurant for the very first time. So now I'll pass on the time to liang POPO.
Oh, wow, but I always say I recently got this new sushi restaurant that just opened. By the way, how to order at this sushi restaurant?
Hi liang POPO, welcome to Kawaii Sushi Restaurant.
Oh, thank you. I'm so happy to be here today.
Okay, so liang POPO, are you ready to order?
Yes, I want to eat the sushi.
Okay, firstly, can you please log into your Facebook using this blue login button?
Oh, this blue button. Okay.
Yes.
Click on it, right?
Yeah, just click on login.
Oh, okay. Okay, I log in.
Okay, so once you log in using the Facebook, we will extract our data from our Facebook page itself to tell you on our store information and our upcoming events that we have on this page. So very simply, if you go into the Facebook tab itself, you then just go into events and you scroll down at the bottom.
Oh, correct. This one.
Correct. So you just click into it.
Oh, click into it.
So at the bottom, you can see all our information of our Facebook, of our store itself.
Oh, okay.
Okay, so now are you ready to order and look at the menu?
Oh, yes. I want to eat. I'm very hungry.
Okay. So now you can click on the order now button.
Okay, I click. Click. Okay.
Okay. So liang POPO, which table number are you sitting at?
Oh, I don't know. I don't have number. You tell me what number.
Oh, okay. So you're sitting at A14.
Oh, A14.
So I'll just key in here A14 for you.
Okay.
And then liang POPO, do you have Telegram account, you can actually use our Telegram account so that you can know when is your order ready and when is your order processing.
Oh, Popo got Telegram. I also go according to technology one. So it's Liang Popo. Yes.
Okay, Liang Popo, please submit.
Submit. Okay. Submit. Okay.
Okay.
Then suddenly my phone vibrate.
Oh, okay, you can use your phone, and then from your phone you can see that you have registered with our with our account page itself.
Oh yeah. They say, wow, so happy. Okay. So I want food. So how do I order?
Okay, so here we have our sushi menu. If you look, we have a lot of variety of food for you to choose from.
Oh.
So from this menu itself, you can actually see the sushi name and then the sushi price for itself, and then you can choose which you want to add into your cart.
Oh, okay. My son say I'm 90 years old. So I better don't eat salmon. Later I go to the hospital. So I choose the chicken teriyaki don.
Okay, right.
Okay.
Easy, just add. Okay.
Okay. Today one person.
So
one
quantity, just one will do?
One. Yes. Okay.
Okay, so you can add into your cart.
Okay.
And then yes, the order details will be recorded for you. And then now you have your order summary of your chicken teriyaki don.
Wow, happy. Okay. I'll wait for the food. Thank you.
No problem.
Okay, thank you, Liang Popo, for the demonstration. Now we will be going through the chef receiving an order request scenario. So as mentioned, the customer will make an order and then it will display the order details to the customer. But on the chef's side, they will be able to view sushi order summary through the chef UI, and the chef UI will request for sushi order detail through our solution. Our solution will then retrieve and return the sushi order details onto the UI, and it will be displayed to the chef. Right, now I'll be diving into the backend. So what happens is that when the customer first create an order, it will be created in sushi order details. This data will be sent to a broker, which is the RabbitMQ, and it will be lined up in a load balancing way. So what happens is that normally in a restaurant, there will be more than one chef. So chef 1 will be opening their own command line, where chef 2 will open their own command line. So what happens is that whichever chef that does not have an existing order, the data of the current order will be sent to that chef. So currently, since chef 1 does not have any order, it will be sent to chef 1. So what happens is that the chef will also be looking at a chef UI, which is on another monitor. So what happens is that the chef UI will then request for sushi order details through the sushi order microservice. Then the sushi order microservice will request for sushi order details on the sushi order details microservice. And then the microservice will retrieve the data and back to the sushi order and finally back to the chef UI. Right, so for our scenario 2, the basic requirements, we definitely have met all of them. We have the microservices as listed, the user interfaces as listed, and also the database as listed.
So now we'll move into the demonstration for our user scenario 2, where the chef receives an order request.
Wow, now circuit breaker, huh? Everyone eating last meal, is it? Wow, so many. Wow, this customer adding stuff. Okay, so I have order ID of 1024. I have to create this order now. Anyway, let's check 1025. They add, wow, lucky it's not me. It's another chef that do it. Thanks to AMQP's load balancing. This is so heng. Then I check, 1024 is for me. And it's from Liang Popo. Oh, nice, order completed. Yeah, man, it's delivered to the customer.
So for our last scenario, customer will check the bill and make their payment. Customer will request for bill using customer ordering UI. It will retrieve sushi order details by using order number from the sushi ordering enterprise solution to the customer UI. Customer UI will retrieve sushi price and name using item ID from sushi ordering enterprise solution, and it will return menu details to customer UI, and bill information will be displayed. So how does this microservice here actually work? Customer UI will retrieve sushi order details by using order number to sushi ordering details microservice, and it will return sushi order details. After this information was collected, the customer ordering UI will retrieve sushi price and name using item ID from the menu, and it returns menu details. After checking the bill, customer will pay through the customer ordering UI, which will send the total price and customer PayPal details to the sushi ordering enterprise solution, which will return the payment status on whether it is a success or failure, which will then be displayed. Customer ordering UI will request for bill. Bill microservice will send total price and customer PayPal details to PayPal API. It will return PayPal status to Bill microservice, which will then display the bill status. So the basic features we had incorporated uses this microservice, user interface, and database.
Okay, so now we'll move on to our user scenario 3, which is a customer paying bill and making payment.
Oh, jialat, E&Q so expensive. No cash, free meh? Faster 走了。
哇，变了咯，还有伤脑筋啊！
Papa, don't go yet, you haven't made payment yet.
What will be payment? There's no cash ba.
Papa, very easy one. You just need to click make payment.
Okay, click. Click. Okay.
Okay, so after you click, you are directed into our PayPal page, where very easy, you just need to click the yellow button, where will direct you into your login account.
Okay. Wow, okay. Wow, very dangerous. I scared got con one.
Don't worry, this is a real PayPal page that we have directed from our own web service itself.
Okay, I think I logged in earlier.
So you are logged in earlier, so now this is a page for your PayPal, and then you can just see your total amount on the top is $6 for your teriyaki chicken bowl, and you can just click pay now.
Okay, pay now. It sounds like an app. Pay now. Okay, pay.
Yeah.
Okay. Process.
Yeah.
Okay.
Okay, so you should know that your payment is succeeded. So you just click OK.
Okay. Oh, so I pay already lah. Okay.
Yeah, so you payment ready. You can go already.
Okay. Okay, thank you.
No problem, Papa. See you again. Bye-bye.
For our sushi app, we have created some additional features, all of which using external APIs. We have used Facebook APIs, Telegram APIs, and PayPal APIs. Our Facebook API will provide our customers customized experiences. Telegram API, which is a specialized Telegram bot, it will inform a recently subscribed user a welcome message and even an order notification when the food is about to be sent out. We also integrated PayPal API as a merchant for a payment gateway for users to pay their bills. Hi everyone, this is a technical overview diagram of our sushi app. It is connected to two main UIs, mainly the customer booking UI and the chef booking UI. It is connected to 5 atomic microservices, which are the sushi order, menu, sushi order details, chef, and bill microservices respectively. 4 of them are connected to the database via SQL Alchemy. The sushi order microservice gets sushi order related information via invocation method from the database. The menu microservice gets all the sushi details that are offered by our sushi shop. The sushi order detail microservice manages the details on the quantity of the sushi taken. In the chef microservice, it acts like a monitoring service that awaits sushi orders sent from the customer. It is automatically load balanced so that chefs will get a roughly equal amount of orders, with the assumption that one chef will clear one order. Lastly, the bill microservice will settle all bill-related services, such as creating a new bill and retrieving bills for the customer.